Hello everyone, this is the first lesson recording for IM1, December 15th, 2020. We are going to be reviewing for finals today. So depending on which period you are, your final is going to be on Thursday or Friday. If you're from my period 4, your final is going to be on Thursday, period 4, 9 to 11. Just notice that for Thursday, for whatever the reason, period 4 and period 3 is reversed. So that means that you're going to have period 4 final first and then period 3 finals in the afternoon. For if you're in period 5, you're going to have it on Friday at 9 to 11 and period 6 is going to be at from 12 to 2. Hey, what is going to be on final? It will comprise of 35 questions, numeric answers, or multiple choice. That means there will be no explain, short answer questions. You are going to need to submit scratch work for Canvas to verify that it is your authentic work. You will have 4 to 2 hours, but we're still considering shortening the time a little bit. So questions are very similar to existing quizzes and unit tests. This means that you really should be looking over your mistakes. So go to your quizzes and unit tests and you can find those by going to Canvas, clicking on the quizzes column, and then you should be able to see all of them. Okay, and make sure you look over your mistakes and see if you can figure out why the question was wrong and what the mistake is so that you do not make the same mistake again. That way, you're not going to be dinged twice for making the same mistake. Extra office hours are available today, Tuesday, Wednesday, and Thursday until 4 o'clock. Okay, just to help you prepare for the finals. If you have any last minute questions or anything like that, come to my study hall and I should be there. But you can also email me anytime. All right, so what we did is we went over some PADEC exercises. So please pause the video and see if you can solve these problems yourself. So what is that bar? Those are absolute value symbols, right? The absolute value is a grouping symbol. That means you need to evaluate what's inside the absolute value symbol first, whenever possible. So you have 3 times 3. 3 times 3 is 9 minus 12. We still haven't taken care of the absolute value symbol, so that stays. Now inside the absolute value, 9 minus 12 is negative 3. Okay, now that you are down to just one number, this is when you evaluate the absolute value of a number. You can't do it at this stage because you have not evaluated. Now that we are down to one number, that's when you evaluate it. What is absolute value of negative 3? That's just 3. Oops. That's just 3 because absolute value function, it always pops out a positive number. If it's a negative number, it just gets rid of the negative symbol. If it's a positive number, it remains as it is. And notice that this is where the absolute value symbol goes away. Okay, now we're just down to a number, and this is my final answer, so I'm going to put it right here. In contrast, number 2 is very, very similar, except we do not have the absolute value symbol. That means you just need to evaluate from left to right. 9, 3 times 3, well, actually, using PAMDAS or JAMDAS, multiplication is before addition subtraction. So 3 times 3 is 9 minus 12. And 9 minus 12 is negative 3. And so the final answer is negative 3 for this. Okay, next two problems, pause the video and see if you can solve them yourself. The first question says evaluate negative 3x plus 4 when x is equal to 20. Okay, that means whenever I see a x value, I can substitute 20 because we're told that x and 20 have the same value. So in this expression here, 3x plus 4, negative 3x plus 4, notice do not lose the negative side. Okay, negative 3x plus 4 just becomes, instead of writing x, wherever I saw an x, I am going to put parenthesis and replace that with 20 plus 4. Because x has the value of 20, negative 3 times 20 is negative 60. plus 4, and that's going to be negative 56. How is this different to number 4? Okay, given that f of x is negative 3x plus 4, this is the function notation of exactly the same thing, isn't it? Okay, so f of 20 just means, you see, 20 is taking the place of where x was. That means in this expression here, wherever you see an x, you can put in the 20. So that becomes negative 3 times 20 plus 4. And again, that's negative 60 plus 4. So again, that is negative 56. Exactly the same answer as previous one, because this is really the same problem. It's just the function notation on the right, and this is just a simple evaluate. Okay, let's look at this one. Evaluate negative p plus 4, where p is equal to negative 2. Again, you want to rewrite the original equation with parentheses wherever you see a p plus 4. Notice that I did not lose that negative symbol right there because that's important. And for p, I see that it's negative 2, so I am going to put negative 2 right here. So this becomes negative of negative, that becomes positive. So that becomes positive 2 plus 4, so which is 6. So 6 goes right in there. What about g of t is equal to negative 2t squared plus 4? Now, in this case, we do the same thing. This is a function notation. So g of t, notice that negative 3 is taking the place where t used to be. Okay, everything else is the same. But g of t means g of negative 3. G of negative 3 means wherever I saw a t, I need to replace it with negative 3. But I am going to put a parenthesis first so that I do not lose anything. Especially when you're dealing with negative 3, you want to use parentheses. Okay? Now, in this case, what's happening in this expression? Negative 2, parenthesis, negative 3. What is the operation between the negative 2 and the parenthesis? It's multiplication, right? There is an invisible multiplication right there. And then to that is being raised. Okay, now we have multiplication and um, exponential expression. Okay, which should we evaluate first? Order of operation, do we do multiplication first or exponents first? It's the exponents, right? So that means we need to evaluate this first and then multiply negative 3. Now, again, negative 3 squared is not negative 9 because whatever is in the parentheses is being multiplied to itself twice. So it's negative 3 times negative 3. Negative 3 times negative 3 is what negative squared is. And then to that, you are multiplying negative 2. Okay? And then finally, you're adding 4. Negative 3 times negative 3 is positive 9. Positive 9 times negative 2 is negative 18 plus 4 is going to give me negative 14. And that's my final answer. And this problem is asking to find the domain of the graph and the range of the graph. Okay, remember, domain is all possible x value. So that means you go to your graph and the x-axis is here. This is my x-axis. That tells me all the values that I need to be considering. All the numbers here on the x-axis are what we are going to be considering. So look where the graph starts. What you can do is you can actually draw a box to confine all of your graph, like so, and then figure out where does the x value extend on the x-axis. It starts right here and it stops right there. So that's where the box goes. It starts from positive 1, and it goes all the way to 7 here. Okay, so it extends from positive 1 to positive 7. Notice that just the way on the graph, the positive 1 is on the left and 7 is on the right, I do the same thing. And in between, we're dealing with the x value. because it's all possible x value. Remember our friend dogs, which tells us the domain is always about the x value, all possible x value, and it is in between those segments, so the alligator mouth always opens to the right with a less than or equal sign because we have those 2 points included. Okay, now let's try for the range. For range, we're looking at the y-axis. Y-axis is the vertical line. That means we are looking at all the values on the y-axis. Let's see how far the graph extends. Where does it begin? It begins right here. This is the smallest number for the rectangle. And the biggest number here is positive 3. So it goes down to negative 5. So it goes down to negative 5. That's the lowest number. The smaller number is on the left and the bigger number is on the right. Just like what you see on the domain and range. Smaller number on the left, bigger number on the right. And this time we're dealing with the range. So we're dealing with the y values. And we're going to use inequality opening to the right. You can read this as all y values between negative 5 and 3. Okay, let's do the same thing with this domain and range. Let's start by drawing a box around the graph, enclosing everything. So that's my rectangle. Now we're looking for domain is all possible x values. That means we are going to go to the x-axis, which is this, and looking at, okay, how far does the graph extend on the x-axis here? The smallest is extend that box down to where it's enclosing it. It's that extends from negative 4 all the way to positive 10 on the x-axis. That's how far the rectangle goes. Okay, so it goes from negative 4 to positive 10, and we're dealing with x values because we're dealing with domain, and the alligator mouth would open like this. That means all possible x values between negative 4 and 10. Now let's consider range. That's all possible y values. That means we go to my y-axis and we're looking for how far does the rectangle extend on the y-axis. It starts on number 2 and goes all the way to number 10. Okay, so that means number 2 is the smallest number and number 10 is the biggest number, and we're dealing with range. So it's going to be y in the middle, alligator mouth opening to the right. That means all possible values between 2 and 10 is my range. Okay, now let's recap linear relationship. Okay, the linear relationship, if you call, always has starting value and growth rate. And that it would be in situations like, for example, in tile pattern or race. The tile pattern, the starting value will be the number of tiles in figure 0. What about the growth rate in tile pattern? Okay, growth rate is how much the growth per figure. So how much is it growing in each figure? How many tiles are being added? Okay, what about in a race? What is the starting value? That's the position at the start. Is he getting a head start, or is he starting at 0 point, or is he starting further back from the starting line? And then the growth rate or the unit rate is the speed. It's usually some distance per time. And what if the situation was bank deposit? The starting value is how much money is at the start, and then growth rate is how much you are saving per day. And then finally, gas in the tank, the starting value is how much how many gallons you are starting with, and then how many gallons are used per mile, per distance. Okay, so when you look at a table, you can figure out the growth, that's the growth rate, by figuring out how much x is changing and how much y is changing. And growth is always delta y over delta 2, or slope is always that. And on a graph, you can figure out slope and y-intercept. Slope is the growth rate, y-intercept is the starting value. And then finally, the equation is going to be y is equal to mx plus b, where m is the slope, b is the y-intercept.